Good day, my name is David Ronin Reyes, and I am a member of Group 4 for CPE 107L. And for my Lab 5 vlog, I'll be doing the vowel and consonant encoder and decoder. And for this project, we'll have switches assigned to a specific name. The 7th segment will only output the vowels A, E, I, O, U whenever a vowel is pressed. So we'll actually encode 10 characters, and we'll only decode 6. The letters we'll be decoding is the letters A, E, I, O, U, and C. So we were actually asked to use the name of one of the members of the group or to combine them. So what I've actually done to maximize our use of the 7-segment encoder was choose the first two letters of everyone's name, and I actually chose to use my full name. So let me just show you my Excel file. So here, so we'll be actually using two applications, which is the Logism application on the left and the Microsoft Excel on the right. So as you can see in my Excel, I have chosen to use my name David Ronin Reyes, and then I've chosen the first names of my group mates Miguel, and the second name of my group mate Justin. So as you could see, I chose the first two letters of each name so that we will be able to see the use of all of the vowels. So as you could observe, it's actually alternating. So it's a consonant, a vowel, consonant, vowel, and so on. So so to actually start this discussion, I've actually divided the vowel and consonant encoder and decoder into two parts. First, we'll focus on the encoder before we focus on our decoder. So for our encoder, as I've discussed earlier, I have chosen this letters. And we actually were given a condition that the vowels A, E, and I, O, U have equivalent numbers. So for A, we have the value 000. For E, we have the value 001. For I, we have the value 010. And for O, we have the value 011. And for U, we have 100. While our consonant, which is only C, is 111. With this, we can come up with this XYZ table. So I've actually created this table so that we could come up with an equation for x, y, and z so that we could actually create a circuit here with a logism file. So as you could see, we will be first start with the letter D. And as I've said earlier, D is a consonant, so we'll have it at the bottom part aligned with our consonant value, which is 111. Now moving on to our A, which is 00, we have that aligned here. And then our R, which is also a consonant, so it's also placed here. Our O, which is 011, is here. And then our U, our U. Yeah, this one is aligned here because it's 100. So as you could see, uh, we have a constant consonant for every area for the orange, purple, yellow, green, and blue. So we can actually now start with our equation. So first, let's start with an x equation. So how did I get this equation? So as I've said earlier, uh, we have corresponding ones based on the uh, values given. So as you can see here, our first one for our x column, it has the same, it has a 1 in its row. This is its row, and the only one it has is u. So we actually have u in our x equation. Moving on to these two ones, since we were not given a condition for this row, we actually need to skip this row. So we move on to this row, the last one. And as I've said earlier, this row contains 1 for all areas. Thus, we could come up with the equation x is equal to d plus r plus m plus j plus u. Now moving on to our y, we have two ones. First, let's start with here. And as we could see, this row actually is aligned with I. Thus, I is part of our equation. Moving on to our next one, we have O in this row, and that's it for this row. So we actually need to put O. And lastly, as I've said earlier, we have all the consonants in this area. Thus, we put D plus R plus M plus J again, then add the I and the O. Lastly, for our Z, we have our first one, which is an E. So we have E. For our Z, we also have an O here since it's 0, 1, 1. So we also have an O there. And again, we have the consonants D plus R plus M plus J. So we actually have two R's there. So I will just put another R for the equation. So we could actually now move on to the decoder part of our table, which is the one here down. So this part is actually similar to the part here. But however, but in this part, we'll be using the letters A, B, C, D, E, F, and G to represent the different areas of our 7-segment display. So our 7-segment display actually looks like this 8th figure here. And as you could see, I've labeled each part. And for the first part, A, here is the B, and the C, D, E, F, and G. And looking at our table, we have the consonants A, E, I, O, U, and C, which could be shown in the 7-segment display by lighting up different parts of the figure. So if we actually remove the D part, we could get an A. So that's what we'll be doing for this part of the table, for our decoder part. So as I've said earlier, A, we could create it by using A, B, C, and not D, then E, F, and G. So we come up with these values for the table. As you could see, the only zero here is the D since we won't need that to be lit up during the display. Now moving on to the E, we only need these parts except the B and C. Thus, B and C are the only zeros for this part. Now we move on to the I, which is represented by B and C. So that means B and C are the only ones for the whole row of I. Moving on to our O, and as you could see, we only need to remove this part to create an O. And that means G is the only zero for the O row here. And now moving on to the U, we get this values since we don't need A and G. So A and then G are the only zeros there. Now lastly, for our consonant, we could say that we don't need this whole part, B, G, and C. Thus, we should have only four ones, A, F, E, and D. So A, F, E, and D. Now with these table, we actually come up with 7 K-maps. So this is A with the relationship with A and X, Y, and Z. And then this is for B, X, Y, and Z, C, X, Y, and Z, D, X, Y, and Z, and E, X, Y, and Z, F, X, Y, and Z, and finally G, X, Y, and Z. As you could see, we have two groups here of 1. And I've said earlier, for A, we have 0, 0, 0. Thus, X should be 0, Y, and Z should be 0. Thus, we have 1. So that's how we got this one here. So that goes for all of the values in our K-maps. So I've actually grouped them already. And as you could see, we come up with the equation A is equal to X prime Y prime plus YZ. Now moving on for our B, we could observe that B and C have similar groupings and placements of ones. Thus, the equation for B and C is equal to Y prime Z prime plus X prime Y. Now moving on for D, we have actually three groups. Thus, we can come up with V is equal to X prime Z plus YZ plus XY prime Z prime. Finally, we have E and F, which are also the same uh, groups and um, placement of ones. Thus, we come up with the equations E and F is equal to X prime Y prime plus Y prime Z prime plus YZ. And finally, our G, which is only this two, we come up with G is equal to X prime Y prime. We could actually now create our encoder. So to start off, I've actually created the circuit area here. So first, we'll be needing this inputs. So let me just place it south, label it as D, have the placement of the label at north, and as you can see, we come up with D, then another one, south, name is north, and DA. So I'll just copy this, Control C, Control V. Control V. So we'll actually need to do this. Right there, V 5 times, and this is our last ones. And I'll actually just change the label. So this is our R, this is our O, this is our R again, and this is our E. And this will be our M for Miguel's, and this is our I also for Miguel. Well, this will be our J for Justin, and our final letter U. So we could actually create our encoder here. So I'll just place this one so it will be easier for me to connect later on. Dar, daro, re, mi, jo. With the given, we could actually say that we'll be using OR gates. We could actually use OR gates, but we could actually use these OR ICs too. So first, our D, we'll actually place it here, D, RR, so all are our R's. Let's connect them together. And then this result should be connected. I'll actually connect it here. So we have DRR and then an M. And then finally RJ. So let me just move this down. There we go. Oh, let me just delete this. And let me place an OR again. Wait, I'll just delete these ones to avoid error. Delete. So where is our D? Delete. Delete. There we go. D R, another R, and then our M, and then finally our J. We actually come up with the first for the given for our parentheses. But this isn't actually uh, our x yet, so we still need to add u. So we will need another OR gate for that. So let me just put that here and then u. So we actually come up with this value. And let me just put the output here and I'll label it as x. Then now we need to put a y for I plus o. So we could actually make a shortcut by just using this one. Oh, made a mistake here. We could actually use this one and then just add an I first. And then we could add it here. And then we need an O. Just this one. So this is the result for our wait, I'll just make it easier for us. So wait, I'll just edit this. So first let's add a O since both Y and Z have O's. And thus we can come up with the first two equations, parts of our Y and Z. So here we actually have, wait, I'll just need to change this, yeah. The value for this two is D plus R plus R plus M plus J plus O. And we just need an I and an E. So I'll just get the I here. I. And this is our Y. And finally, we need an E, which is this one. And we could come up with our Z here. Z. So we could actually delete these ones. Uh, so I think we actually made a mistake since our I should be used in the Y part, which is this one. So I've actually made use of the M. So let me just delete this one and let me have that placed there. There we go. So now we actually could check this. So if it's a D, that means all ones should light up. Correct. If it's an A, 0 should light up. See, okay. And then if it's a R, all should light up as well. An O, it should light up at 0, 1, 1. Correct. An R, all. An E, 0, 0, 1, so Z should light up. And then for an M, all should light up. An I, 0, 1, 0, so Y should light up. And then J, all should light up. And finally, a U, X should light up. So we've actually done our encoder part. Let me just save this. And we could actually move to the decoder. So let's move on to our decoder. So We'll actually connect the decoder for our x to our XYZ. So let's consider XYZ as an input. So X, wait, I'll just put X and then AY and then AZ. So what I could actually do now, since we could observe the values here actually have prime values, so a not would be actually good. So this is the value for X. This is for Y. And finally, this is for Z. Oh, just delete that. Let me move that. Yeah, there we go. There. So we could actually start with our A. So we'll need an AND, and we'll actually need a OR. I think it will be better this way. So let's first start with our AND. So X prime. And then Y prime, just this one. Then Y and Z. Y and then Z. So that's it for our A. Let's just have it connected here. And this one as well. And we actually get our A. Let me just label this as A. And we could now move on to our B, which is Y prime. Let me just get Y prime, which is this one. Y prime, Z prime. And then X prime Y. So we need an X prime. X prime, and then an Y. So we could actually come up with, so let me just move this here, A, and then come up with the values B, B, and then C. So as you could see, as I've stated earlier, B and C actually have the same equation. That's why I put it here. And I think I actually made a mistake, so let me just correct this first. So what we've actually done here is create the Y prime Z prime. So we'll actually need that first here, and then this one here. There we go. So we're actually done with our A, B, and C. Let's move on to our D. So we'll actually need another AND gate for this one. AND gate. And we could actually use an X prime Z. And then these values could be actually added here. And then we need a YZ. YZ. Y. And then a Z. We'll actually just need this one. So now, oh, I think I made a mistake. Let me just edit this one. Delete. So what did I do wrong? So as you could see, this is the output. Oh, I've actually done correctly so far. There. And this is actually the ground. So I need to add this one. Now we have these part. We could actually go to X, Y prime, Z prime. So X, Y prime. Before adding Z prime, which is actually this one. Z prime, so we actually get this value. Let me just add this. And then we come up with the letter D. Let me just edit this and add the letter D. D. So what we've actually done is the letters A, B, C, D. We could actually finish off with E, F, and G. So let me just lower that. There we go. So I'll be needing, I think, an OR. So as we could see, we have actually created the X prime, Y prime for A. We could actually just copy that to save, to limit our use on our gates. So this is that one. So there we go. This is X prime, Y prime. And then we actually created Y prime, Z prime for C. So we actually just need to look for that one. So I think it's actually this one, Y prime, and then Z prime. And then we actually need YZ. We've actually created that here. So this is it, YZ. So let's just connect that here and here. And we could actually come out with the equation for E and F. So we're actually done with the E and F. And we actually saved some space. So let me just put that here, E. And then finally, F. Now for our last one, which is X prime, Y prime, you could see that we also use that for E and F. So this is that one. We could actually just wait. We could actually just have that pointed directly for G and label it as G. So now we're actually done with our decoder. Let me just save this. Let's just first check to ensure everything is correct. So for A, we actually need the D to be the only one, which is a 0. Let's see, our E should have A, E, D, E, E, F, and G. So first 0, 0, 1. Correct. Our I, 0, 1, 0 should only have 2. Okay. Our O should have all letters split up except for G. So let's go to our O. Correct. And finally, our U for the vowels, we have 1, 0, 0, and we should have the letters A and G uh, as 0, which is also correct. Now finally, our C, we should have 4 letters A, D, E, and F. A, D, E, and F. So we're actually done with our decoder. Let's start creating our main. Uh, so for that, I'll be using a button. Let me just D and have it facing south. Control C, Control V. And this one should be A. DA. Control C, Control V, Control V. We'll actually be needing 5 of these. Control V. And let's just relabel this. Raw, Re, Mi, and finally Ju, Ja. So I'll be using first the encoder. So let me first move R here and here. So we could actually start with our placement D, A, R, O, R, E, M, I, J, U. Now we could actually connect this once to our decoder. And now we put our 7-segment display. So in observation, I think this, I don't really know the letter here. So we could actually have a try. So this actually should stand for G. So let me just edit that one. Let me place these ones here. So let me label this encoder. Have it facing north. Oh, east. Have the label facing north. This one is decoder. There we go. For our first one, we need a G, so it should light up. Then let's try this one. And it should be our F, I mean letter E. F, I mean. So is this our F? Could actually delete the extra ones. Now let's look at this one. I think this should be A. Yeah, it's correct, A. And then this should be B. Correct. Now let's check our lower ones. So I think this one is our E. Could actually just put it here, E, and then F, and then D, and then finally our C. There we go. Let me just put this one, and this one. So we've actually come up with this vowel and consonant decoder, 7-segment decoder, encoder and decoder, encoder and decoder. Okay. Now let's check if we are actually correct. Let me just move this closer. There we go. So to start off, let's start with DA. So D. Oh, let me just change the mode. D. So D is a consonant, thus we have a C. A, we have an A already. R, we have a C for consonant. O, we actually have an O. R, consonant again, so C. And then E, we actually have an E. M, we also have a consonant, so it should be a C. I, which is correct as well, I. J, we also have a consonant, so it's a J. And then U, we also have a U. So we've actually finished our um, vowel and consonant encoder and decoder. So that's it for this Lab 5 project. Thank you for listening. Once again, I am David Ronin Reyes of Group 4.